So let's see how the GMask can also be combined in conjunction with the 3D tracker. So the 3D tracker workflow has actually changed quite a bit since previous versions. In previous versions, you were actually limited to a single track, 3D track of a camera at any given time. In the context of 2012, we've actually significantly revised the workflow so that actually you are no longer limited to a single camera track, but in fact can have as many as you want coexisting live inside of Action until you pick the one that you actually like the best. In order to do that, we've actually implemented a new node that we call the analyzer. Now, the analyzer is supposed to work with the media. So you have to select the media before you drag an analyzer into your schematic. When you double-click on the analyzer, what will happen is that even though in the schematic there's a new structure that was created, you're automatically switched to the view of the analyzer, and the shortcut of that view is F7. So that's kind of like a self-contained world in which you can deal strictly with the problem of the track, which is the track contained in this particular analyzer. Looking at the structure of the analyzer, what you will find is that you automatically have the analyzer node, which will carry the interface of the 3D tracker, which was streamlined, an FBX camera, which will receive the tracking data, and also a surface, which will be positioned and framed always perfectly by the tracked camera. The whole thing acts as a block that is autonomous until you actually decide to bring it up into the actual perspective of the schematic of Action. Again, you will notice that the analyzer has a monoscopic version, which you will use, of course, on regular footage, but it also has a stereo version, which will generate an FBX stereoscopic camera. The workflow is actually going to be identical between the two. So connecting to the GMask, if I switch to the F7 view of the analyzer, here I take a look at this shot and I see that I actually have this truck that's moving forward and I have this camera. So in a shot like this, I could be interested in actually asking the tracker to typically exclude the truck from its analysis because it may just disrupt the quality of the tracking data. In previous versions, I actually had to do a roto mask outside of Action to then feed it as a constraint mask to the tracker. In 2012, this is no longer required. Being in the F7 view, which is the analyzer view, you can go ahead and double-click on the GMask, and directly in that view, start adding a GMask. Now, what you will notice is that in the schematic, it was automatically parented to the image that's underneath the analyzer. This is because we want to make sure that even after we've done the camera track, the GMask will continue to be consistently associated to the image from which the tracking data was extracted. Now, if we go to the GMask menu, we are actually able to access the shape tracker exactly like I showed you earlier on. So I can go ahead and let's try and do a background track, see what happens. Go ahead and shape track, and it's going to do its best to follow. If it's going slightly astray, I'm just going to move the points a bit closer together, make sure that they're closer to the truck, and resume the tracking. And again, this is all to make sure that I just create a mask that will tell the 3D tracker not to consider what's inside of this particular portion of the image. So I'm resuming the tracking. It's going a little bit astray. Let me make a modification. There we go. Like this. And I'll resume the track again. There we go. So let's see what we have. We have something that roughly works. It's going to be enough for me to tell the tracker, don't look at anything that's inside there. Now, let's go into the analyzer actual UI. And what you will see is that, well, essentially it's really pretty much the functionality that you had in the original camera tracker, except it's been, again, streamlined so that things align in the order in which you do things. So typically when you go to camera tracking, the first tab that you will see is the analysis. So the functionality of the 3D tracker has actually been augmented so that you can actually specify lens correction before you actually start tracking. in this particular case, there won't be a need for me to do any lens correction. Or at least there doesn't appear to be any important lens correction. So I'm just going to switch it off. Lens correction can actually be applied before you do the tracking or even after. However, if you do after analysis, the tracker will actually ask you to do a recalibration of the tracking process in order to resolve the camera to take into consideration the distortion that you've added or removed. Now, on this particular side of the UI, you will see that actually we have a new section that says constraints. And as you see, I have a pop-up here that says track outside shape, and it's also saying ignore the matte, and this means the matte of the actual media that I'm currently tracking. So I'm going to let it to track outside shape, and at this point, if I go ahead and select track forward and backward, and set this to free 3D motion, track outside the mask, the shape, and let's go and see what happens when I do the tracking. So the camera analysis at this point is kicking in, and we'll see what kind of results we get. Okay, so you see now what you will see is that within the actual shape, no trackers were added. So it's actually very simple. During the tracking, the camera analysis, just to go ahead and point and click to draw a shape track it, and then tell the tracker to essentially ignore anything that's within your shapes. You can actually have as many shapes as you want to protect certain areas or to exclude certain areas from the tracking process. As many GMask that you want underneath this, all the constraints are actually added together. So when you press F7 a second time, you're actually switching to the actual 3D tracker view. So F7 the first time only shows you the 2D trackers. F7 the second time shows you the actual 3D trackers. So it's time for me to move on to the fine-tuning of this. As I can see, there's a couple of problems probably with this particular track. So I'm going to go ahead and refine a little bit this and get rid of things that are not necessarily good data. Okay, this is a much better result. As you see, I can see that the crosses that I have in the foreground are much bigger, and the ones that are in the background around the house now are much smaller, which means that the perspective of the shot was much better understood. Now, one of the things also that we've added in 2012 is a brand new object that we call the point cloud. Now, the point cloud is an extremely powerful replacement to the axis creation. In previous versions, you could only select a bunch of trackers and create a grapevine of axis that exists inside of Action's perspective. We've replaced with, well, it's not replaced, you can still create axes, but we've also added a new object, which is a point cloud. The point cloud is a much more efficient way of dealing with bringing back information from the tracking into the Action perspective, because it's going to be a single object that carries all of the trackers into the Action 3D space. But however, it will still let you snap to any of the points that it includes. So let me, for example, here go ahead and select the trackers that appear to be on this particular sign here. So those are the ones. And by the way, you could anytime press spacebar F7, which actually switches you to the working view of the tracker. So this is very similar to spacebar F4, which switches to the working view and the perspective. Spacebar F7 is the working view of the actual analyzer, where you can actually see your point cloud in 3D space and check out if things are relatively okay within the perspective of your shot. So you see the particular points that I'm interested in the sign appear to be located over here. So let me switch back to the F7 view, and I'm going to go ahead and select them. Oops. No. Oops, sorry. There we go. That was not in move mode. Okay, so I'm just going to select them. And at this point, what I can do is create a point cloud. So let's, did it work? There we go. So what happens is that you see all of a sudden there's this new object that is parented to the analyzer that was created. And what this has done is has actually created something that exists within the action perspective. The point cloud has its own set of parameters. And as you see, I can change the display. Okay. I can change the display of these points, and the interesting thing is that if I bring any object inside of my my perspective, I can actually snap to any of these points inside of the 3D space of action. So let me switch to F4, which is the result view, and I'm going to ask action to now look through the camera that just got analyzed, which is camera number 1. Now, I can go ahead and hide this particular surface that I don't need, and everything should actually be quite consistent. With one interesting thing is that the point cloud, again, at this point really exists inside of Action's 3D space. So if I were, for example, to add anything, any object, let me just add a 3D text at this point. Okay. I'm going to select its axis, holding the Shift key and moving it around. As soon as I touch one of the points of the point cloud, it snaps it in 3D space, putting it where the points are actually located in 3D space. I can go ahead now and hide my constraint mat because it's no longer going to be useful to me. But again, here, I can then change the scale because obviously it's a bit too big. But you will see that now it actually is glued and stuck to the actual object in 3D space for which I created the point cloud. If I go back to the analyzer view, I could again, hit F7 a second time, and let's see if I could, for example, hook anything up in the distance. So I'm going to go ahead and select these points over there. There we go. Create another point cloud, hitting the Create Point Cloud. There you go. So the point cloud has other hidden functionality. When I did the snapping here, I didn't put any particular, I let the point cloud just be kind of like an object that has no axis properties. On this particular point cloud, what I'm going to do is actually switch to centroid transform. What this does, it actually turns the point cloud into an axis that has an average coordinate, which is the average of all the different points of which it is comprised. So if I now parent anything to the point cloud, it will actually immediately snap to that average position in 3D space. So if I do that, for example, with a light now and parent it here, well, the light will actually be located in 3D space. Let me reset the coordinates of the light so that it's not, so it has a, and so at this point, the light is actually located in 3D space at the right place. If I were now, for example, to add our friend the lens flare, it would actually properly navigate in space and actually get occluded by the objects that are in front of it if I wanted to. So I prepared a little example here, which actually, instead of a 3D text, actually has an oval that hides the panel, so that the occlusion can actually be done when the panel moves in front of it automatically. So essentially, the GMask can be used to do multiple things. It can be done also to either tell the tracker to ignore certain regions for the analysis, but it can also be used also as a tool to generate occlusions within the 3D space. And in conjunction with the point clouds, you have a workflow that allows you to instantly locate and position objects in 3D space inside of the action space and automatically even orient them depending on the options that you choose for the point cloud.